with us today, we have Jared Atkinson. How's it going? Do you want to do maybe a quick intro?
Yeah, sure. So my name is Jared Atkinson. I'm the Chief Technology Officer at SpecterOps. A lot of you probably are familiar with BloodHound, which is a product that we make both for the open source community and the kind of enterprise customers. And that's kind of, I'm going to be, if you're familiar with it, it's kind of comes from like a red team background, but I'm going to try to flip the idea to where we're talking about how defenders can actually leverage the insights or the information that exists within BloodHound to kind of make their decision making a little bit more efficient.
Awesome, awesome. Yeah, Bloodhound is one of those things that I've heard countless times about, but I've always, for some reason, been scared to really dig into it. I think it's because
Sure.
like AD, you kind of like at AD, I'm like, ugh, I'm
Yeah.
worried. So
Yeah, yeah.
very curious to see.
There's an interesting there's this kind of like new push by a lot of these identity-based companies to say things like identity is the new perimeter, and the premise there is to some degree that I don't need to compromise your on-prem environment because I could go straight to Intra or to whatever your cloud applications are, and that's true. But there are ways. There is value in still compromising like your on-prem Active Directory or even Mac fleet because that's where people are using those cloud-based resources, right? And so the general idea is I've kind of posited this idea of a lot of us are familiar with this idea of data at rest and data in transit. And the general idea is if you're trying to protect data through encryption, for instance, the state in which it exists matters for how you're going to approach that. So the way that you encrypt data on a hard drive is different than the way that you protect data as it's traveling over the wire. And I like to think of that metaphor kind of applying to identities as well, to where you have identities at rest. That would be like your user account, right? So I've registered a user account in Intro or in AWS. And then identities in transit, which is once I've authenticated to that system, I am establishing a session. And then attackers are able to either say dump your credentials or steal your credentials, right? And that would be targeting that identity at rest. Or they can also do things like steal your browser cookies or steal your token on a Windows computer. And that would be targeting your identity in transit, right? And one of the big problems is that when you start to think about all the different mechanisms we have for identity security, things like MFA, password vaulting, all these different solutions, very often those are protecting identities at rest. So they're trying to stop the identity from going to transit. But the problem is that identities are meant to be in transit. And so where are they in transit, most likely? And that's in your on-prem environment, right? Because that's where people are using those identities. They're logging into systems, they're accessing resources, things like that. And so it's still very advantageous for attackers to go on-prem to get access to all of those identities in transit. Of course, now they have to, one of the reasons why they might not want to do that is because of things like EDR and all these security tools that are, focused around the on-prem environment. And so there's kind of a give and take there.
Yeah, I mean that's definitely true. I think the other part of that is, as somebody that's historically kind of focused on the endpoint, is as soon as you get into I like that identity in transit, it's at the application layer.
Mm,
And an EDR typically will target kind of the operating system layer. That's where it
sure.
started. As soon as you start to say, well, this is at the application layer, then you start to ask, well, which one, right? Is it
Mm,
Chrome? Is it Firefox? Is it Edge? Is it like some other random thing that's on the box? And the reality is those are so completely different one from the other
yeah. Oh, yeah.
that I yeah, it's scary. It's scary. I'll just leave it at that.
Yeah, no problem. So I think what I want to show is I'm going to show Bloodhound. I'm using the Bloodhound Enterprise version just because it's hosted for me and I don't have to worry about hosting it. But everything I'm going to show is in the free, what we call Community Edition. So anybody that's on the call would be able to replicate this without paying for anything. Pretty straightforward. So just to kind of give you an idea of the original use case of Bloodhound. So imagine that this is like Google Maps, and I'm an attacker, and I get access to a computer. Maybe I phished a user on this Achilles computer, and then I want to say, oh, I want to take over domain admins, right? And so I'm going to look for domain admins in the domain at citadel.covertius.local. And now what it's doing is it's giving me options for different paths that I can take as the attacker that would allow me to leverage my access to this Achilles workstation and eventually have control over the domain admins group and then control over the entire domain. And so just to kind of like how we would start to talk about this is this Achilles workstation has a user that's logged into it called mwrite_a. That user is a member of the desktop admins. That desktop admins group has admin over Apollo and Heracles. They both have sessions for different users that have different kind of control, right? So this SQL service account, for instance, has admin over another computer called Dionysus, who has a session for a Robbins_DA, who is a member of domain admins. And so that kind of tells me as the attacker, what are the steps that I need to take to get from point A, where I got my initial access, to my final destination, which is domain admins, or what you could target whatever you want, really. So that's kind of like the original use case. Now, as a defender, the question is how do I leverage this information to kind of like prioritize? One of the big problems that we face in defense, I think, especially I see both Nick and Andrew both were in the Air Force with me, and we have this problem where you're building detections. You have a detection engineering capability, but the real problem is how do I prioritize the things that I'm looking at, right? Because there's too many behaviors, there's too many attack techniques, there's too much tradecraft for me to focus on everything. And so I have to say, what is the biggest bang for my buck? And one of the ways that we can do that is we can start to kind of like flip things on their head, and we can start to look at, we have this concept called tier zero. So this is this idea, it's kind of Microsoft's tiered administration approach. A lot of you might be familiar with like their Red Forest deployment, or just kind of different tiering ways of managing your Active Directory domain. Tier zero basically implies any object in the domain that has control over every other object, right? So if I compromise a tier zero resource, I now have control over the entire domain. And then as an attacker, I can leverage that to kind of as a means to reach whatever end I want, right? So any system I will have access to. Common examples would be like domain controllers, domain administrators, the domain itself. But there's tons of different kind of things that fit into that kind of category of tier zero. Now, what we're looking at right now is we're able to query and say, show me any non-tier zero asset. So these are just normal computers, normal users. They're not in that tier zero category, that have a single hop path, right? So there's only one step. They're one step away from tier zero. So for instance, this Dionysus computer is just a normal computer, but this domain administrator, a Robbins_DA, is logged on to that computer. And now if I have control of Dionysus, I have the ability to dump their credentials. I have the ability to steal their token. I can inject into a process that user is running under and now have control of it. And so that would be like one step. Another one is this JDimic account, which has the ability to change the password on several domain administrators, which probably maybe imagine that's like a help desk user who has the ability to change passwords. And then you have, like, for instance, this random user down here, W Schroeder, that has the ability to DC sync the domain, right? So it's a normal user that's misconfigured to have the ability to DC sync and therefore steal the password for any user in the domain. So that's kind of like, this helps me to start to prioritize. I think of a lot of times when we prioritize what we should be building detections for, we rely on threat intelligence. And I think of threat intelligence as kind of fitting several categories. There's imagine that there's kind of like global threat intelligence, which are general trends that we're seeing across threat actors, and we start to say, like, what are the types of tradecraft that threat actors are using in general? You have the ISACs, which maybe are like focused more on industry verticals. So I'm a financial services company. I look at the types of reports that are being generated by FSISAC, or maybe that are of threat groups that are targeting financial services companies, and I'm able to like kind of narrow that scope a little bit. But there's this big problem to where we're making a leap where we're saying the things that we've observed a threat actor do in the past is representative of what they want to do in the future, right? And that's probably true to some degree, but I don't think it's obvious that it's always going to be true. It's also not obvious that threat actor is going to be the threat actor that I end up facing kind of in the long run. I'll finish this point, and then I see that there's some questions coming in, so maybe I'll stop to answer those. But then you have this idea of there's this like philosophical concept that I like called the agent arena relationship, right? So this idea that the threat actor is the agent who is trying to have some effect, and then the arena is your environment, and the arena, the environment, inherently constrains what the threat actor is able to do. And so what we're able to do is kind of almost do a Venn diagram where we say, what does the threat actor want to do based on my threat intelligence? And then what does my environment facilitate them doing? And then you look for like kind of the overlap there and you say, okay, I see that this threat actor likes to use DC sync. I see that there is one instance where a non-privileged user, this W Schroeder account, can DC sync this domain. Maybe that's where I want to put my effort. So I'll kind of pause there real quick to browse the. Yeah, unfortunately, this OS test environment here is like a BloodHound Enterprise test instance, so people won't have access to it. Let's see.
I got a question. You don't mind me jumping
Sure.
in?
Go for it.
So first, just stepping back real quick for everybody who's
Yep.
maybe not 100% sure about all these techniques you're talking about, but BloodHound's really, really awesome at drawing that map of how to get from somewhere in the environment to another place in the environment. Generally, it's all the privilege escalation lateral movement you need. And each of these lines is a different technique, right? So DC sync is a malicious technique. There's pass the hash. There's Kerber roasting. I'm going to post a blog post I've dropped with a few of these techniques. And my question, Jared, is in the last, I don't even know, 5 years or so, are there any new techniques for moving around on this map that weren't the same we were looking at, 10 years ago? Has Entra and hybrid environments changed anything? Is there anything new about how attack?
Yeah. I don't know that I have. We're gonna give it a shot. This is like a live demo that I didn't prepare for, but we'll see. Okay, I think this might give us something. Let's just do. Okay, so there might not be a path here. Anyway, that's a good question. So a cool thing about BloodHound is when we first started with BloodHound, this was in like 2018, I think. We had 3 nodes: computers, groups, and users. And then we had, I think, like 7 edges. So admin 2 has session, member of. This is like a user is a member of a group. A group has admin on a computer has a session for a user, so that user's logged in. But over time, we're constantly trying to like expand the graph, both within a single domain, so like Active Directory domain or an intra tenant, but also across platform. So what I'm trying to show here, but I don't have a good. Let's see. Let's just see if we can. Is that going to give us something? I don't have a good one planned out, and I don't know if I have the appropriate data loaded into this tenant, but there are like cross-platform attack paths to where you would be able to show here's a user in an Active Directory domain. That user has an attack path to take over some other user. The other user has a synced account to where their Active Directory account is synced to an intra tenant or intra user. And then you're able to kind of like jump over that and gain access to an intra tenant. And then within the intra tenant, there's an attack path to take over full control. I think there might be. Oh man, let's see. I'm kind of just going off the top of the head here, but we might be able to AZ user. So this is Cypher. It's a query language that lets us kind of ask a bunch of questions about the data that we have associated here on the relationships between different users or different resources. And so this is an example to where we've just recently released this idea called Open Graph, which lets you design kind of like a graph model for different platforms. So in one case, we've done GitHub. And so these are GitHub users, right? So Harmjoy, Versace, SO, ND. And then what we've done is we're using Intra for single sign-on. So imagine that this W Schroeder account is synced to this Harmjoy account in GitHub. And so if you have an attack path or you compromise this Azure account, you've necessarily compromised this Harmjoy account. And therefore you can access all of the code that Harmjoy user has access to. And then you can also do things like audit access within your GitHub organization. So one thing we found, for instance, is that when we started auditing it, our tech writer had the ability to write to the BloodHound enterprise source code. And so if you were to compromise our tech writer, who's supposed to just be like checking for grammar and doing that kind of stuff, you would be able to make changes to the BloodHound source code, which is obviously not something that we would want as an organization. And so that's something that we kind of are able to look through and evaluate.
So that's cool. Not necessarily a new malicious technique, but a new expansion of Bloodhound to sort of encompass more of the map,
Yeah.
specifically around like synced users and single sign-on and things like that.
There's also new techniques like it's not new necessarily, but it's newer, I guess. We've released attack paths for MS SQL. So you have like MS SQL servers. There's been known tradecraft for quite a while, but it's hard. It had previously been very difficult to kind of like have that all in one place to where you can make decisions off of it. And so now you can start to look at and once you start releasing this, you see how frequently MS SQL pops up in a typical domain. Things like SCCM, Active Directory, Federated Services, those all use MS SQL backends. And so now I have the ability to map out how control over an Active Directory user gives me control over, for instance, a SCCM database, which then gives me the ability to deploy malicious code to all kinds of different computers. I don't have a test data set that would show that here, but that's all the types of things that we're seeing.
So those different types of attacks, I'm going to call,
Sure. Yeah.
Are they expandable? Like, is that something where I love this example because yes, it's fairly clean cut, right? Meaning,
Yep.
like, hey, you have access over this account, but would it be possible for like at the community level to go and
Yep.
say, hey, I'm going to add an attack where if there's a GitHub action in that repo that can do X,
Yep.
now that's a new, it's a new edge in the graph, and like, we can expand on that.
So this is like our brand new capability, which like I run the research team, and traditionally when the research team has, what we're doing constantly is trying to come up with new tradecraft, to Andrew's point, where we're trying to find what are new ways, what we call like takeover primitives that would allow what is a permission on a computer, let's say, that would allow me to take control of that computer, right? And so for instance, maybe I can write to I could write the password to the computer, and now I have control to log in and things like that. And when we would come up with new research, that would take there was a long dwell time between when the research was published and when we would get it implemented into BloodHound, just because it was an engineering problem. And now we've released this thing called Open Graph, which lets us kind of create this arbitrary schema that we can input whatever we want. So, for instance, we currently have support for 1Password, GitHub, Jamf, which is like the kind of distributed management system for Mac OS that's super popular, MS SQL, Snowflake. And then we've had two people from the community that have written their own. This was released at Black Hat, so these people, like, they were on it, right? One person wrote it for Ansible Tower, which is, I guess, like a management system for Ansible deployments. And another person wrote it for vCenter, for VMware. And we've seen lots of tradecraft targeting ESXi in the past year. And so, and I think it's like logical. So imagine that a lot of organizations are using Active Directory user accounts and groups to manage access into vCenter, into their ESXi clusters. And then also you're literally running your Active Directory systems as VMs in vCenter. So like a lot of people run their domain controllers as ESXi VMs, right? And so if I control your vCenter, I control your domain controller, and that's a new class of attack paths, basically.
Is this Open Graph library, is that only sort of the data structure definition of those attacks, or does that include, like, let's pick vCenter? Does that include the code that does the data acquisition to evaluate?
Yeah. So they're all going to be slightly different. Let me go back real quick. The thing that Open Graph, this is actually the most exciting thing probably about BloodHound at this point. There's a schema that says this is what your data should look like. So you collect from a lot of times, like if it's GitHub or it's Snowflake, there's like a REST API that you would hit, and you would say, like, tell me all the users, and it's going to give you back the data in some format, and then you just have to kind of adapt them to this specified format. So let me find an example. So it's literally this simple. You have to give it a unique identifier. A lot of times the system is going to have a unique identifier already kind of figured out. Sometimes that's not the case. Snowflake is an example to where that's not the case. You have to define the node type. And so like imagine that there's a person, but like it could be a Snowflake user, it could be a Snowflake database, a Snowflake table, so on and so forth. And then you define the properties. And this is just like an arbitrary hash table or dictionary of properties, where you have a display name and properties. You could give it integers or strings or date times and things like that. And then you just ingest it. You kind of put this wrapper around it here where you say, here's my graph. I have nodes. I have edges. You relate those to each other. You ingest it and you're good to go. Now, then you have the actual model. So this is an example. This is a community model by this guy, Moore David. And he went through and analyzed what vCenter permissions look like, right? And you're probably gonna get a wide range of completeness, and like there's going to be a wide range of, like, some people are going to do like the bare minimum to kind of like, it's going to be very utilitarian. Others are going to do very like robust modeling. But let me see if he has a picture. I'm pretty sure he had a picture at one point. Maybe this is it. So he's like looking at, for instance, here's a vCenter user. Those are members of vCenter groups. They have permission over like this network, so on and so forth. Here's this. I think this might be, they have VMs, and those VMs might be related to Active Directory computers. And so all of these kind of, I call them extensions. We don't have a good word for them, but all of these extensions in Open Graph are open source, right? And so like, here's my GitHub one. You could just click on it, and I've had several, apparently I have more pull requests that I haven't addressed yet, but people, like, literally a guy from the GitHub security team is like giving me feedback on how I'm doing this. And apparently the GitHub's deployment of GitHub does not have the same limits as ours, as you can imagine. So he like ran into an issue to where he has one repo that has 57,000 branches. And let's just say the collection component of that was not made to be robust to 57,000 branches. And so it took a long, it keeps timing out. And so we're trying to like debug how we could possibly address that, for instance. So it's fun stuff like that.
It's a bit disappointed that you didn't test for that many branches, though.
Oh, no. Okay. Come on, Scooby. Okay. I think I saw, Nick, you might have had your hand up in the chat at one point in the past. I don't want to miss anybody's questions.
I was just waving hi. You name dropped me, so
no worries.
We were doubling down on that concept. I liked we both like takeover primitives.
Yeah.
Your philosophy. Anyway, taxonomy is the hardest piece of any of this.
Yep. That's there. Okay, so like, we'll talk about a takeover primitive real quick, and what kind of there's this is not super detection. This is just kind of like the theory of how BloodHound works, but I think it's useful for even defenders to understand this. Okay, so imagine that there's an edge that connects this user account to this domain, right? And in this case, it's a DC sync edge. There's actually I thought DC sync was a composition edge. Okay, so imagine that there's several different permissions that a user can have on a domain, but those permissions don't necessarily imply that you have control of the domain. They just imply, like, maybe you can read users from the domain, right? But that's useful in some context, but it doesn't mean that I can take control of the domain. A takeover primitive means that I have the ability that if I traverse, so each of these are called edges, these arrows, right? In order to traverse an edge, a lot of times there's one, this is what Andrew kind of mentioned, there's one or more kind of like tradecraft primitives or behaviors that I can implement in order to traverse that edge. So like a has session edge, I can credential dump to traverse a has session edge. I can steal a token, so on and so forth. But when I do a takeover primitive, that means I have control of this node, and then I have the ability to traverse any of the outbound edges. So maybe there's like this outbound trust from the Citadel domain to this Covertius domain. And so that means that I would be able to now have some sort of access into Covertius because I've had a takeover primitive. I had control over that account. Maybe this is going to be a better idea. So let's say I get access to this IT workstation computer here. I have a user called mwrite_a that's logged in. We can start to look at like, who does mwrite_a have access to, right? So we could run that query, and we start to look at let's see, domain admins, right? So we could start to see what types of control we have. And so this mwrite_a is a member of desktop admins and then has admin to Apollo. And so the idea is that if I have a takeover primitive that grants me control over mwrite_a, I necessarily have the ability to compromise Apollo based on the way that takeover primitives work, right? And so admin 2 would be a takeover primitive also. One of the things that I think is, I know we're running short on time, so this is one that I think is kind of useful from the how can detection engineers actually use this, right? So the first question is how do we prioritize what we should look at? Well, here is the overlay of what are the most critical edges or most critical relationships in our entire domain. So these are where non-privileged users have the ability to take over or control these highly privileged systems or domains or users, right? And so that's maybe where we should, when we're a detection engineer, might want to start thinking about what does it mean? What does allowed to delegate actually mean? Well, there's some information about how would you abuse that? You can look at that and you can start to test that out and build some hypotheses around those. But we have another problem, which is on the other end of kind of the detection lifecycle, which is where I have an alert. And one of the problems is how do I might have more alerts than I have time to process. And how do I choose which alerts to prioritize? A lot of times what we do is we have the alert category that it falls into. So the detection rule that the alert was generated from, we kind of class all of the alerts from the same rule as if they're the same criticality, right? So imagine that I have a credential dumping alert on sales workstation and IT workstation. I have two alerts. They're from the same rule. They're both about credential dumping. But now I'm trying to decide, how do I choose which one to prioritize? And the answer comes down to context, right? What's the context around that computer? And so the logical first step would be who's logged into that computer, because if you're dumping credentials, the idea is that you're trying to take over any accounts that are logged into that computer. And so we can actually ask that question. And in this case, we have a sales workstation and we have this B Hawkins user. And in this other case, we have IT workstation and we have the mWrite_A user. And so what we can start to do is we can ask questions about, does mWrite_A have an attack path that allows them to take over the domain? And the answer is yes, they do, right? So there's this attack. If I dump credentials on the it flipped on the IT workstation, I now have an attack path to take over the entire domain. So that's critical, right? That's a big problem. But this B Hawkins user, we could ask the same question. And we see that nothing, it says not found, path not found. So down here, this B Hawkins user is just a normal user that doesn't have any attack paths, nothing crazy. And so imagine that you have like a SOAR workflow set up to where you get this credential dumping alert. You immediately ask what users are logged in. Are any of those users tier 0 accounts in the first place? Do any of those users have attack paths to tier 0? Maybe you have a certain system that you really care about. At one point, we were doing a red team and for an airline, and the airline asked us to look at their loyalty system and how we could take over their loyalty system. So maybe what they do is they say, are there any paths from that user to our loyalty system? That'd be useful to kind of discern. And then that allows you to have like this contextual enrichment that tells you about the prioritization of those different alerts, even though the alerts are ostensibly about the same activity. I'll go ahead and probably stop there because I think we're running up on time. But
I mean, this is fascinating stuff. You got a lot of ideas, I think, and a lot of folks going. And I love the fact that the open graph part being open source. I think it's the key to go, between, hey, this is the thing we use internally, and a couple people use it, and like now the whole community can actually.
Oh yeah. And that's the thing is like that gives organizations that maybe have, I think of I was talking before we started about those Air Force exercises, and there's like Air Force systems that are proprietary, maybe nobody even knows about them, and they're really important. And we used to be in these exercises tasked with defending these things, but we never actually knew like what, there's this weird thing to where you talk about a system, and a system isn't literally just one computer. There's a bunch of things, like there might be a file share that's associated with it. There might be multiple computers, multiple groups, multiple users. And so you can start to kind of like map out what that looks like using Open Graph. And now you have like a very specific representation of the problem set that you're trying to protect. And that really is quite useful. It goes back to map the mission, right? Right, Cook? That's the kind of a thing that we used to do is we worked with organizations in the military to try to understand like what are the critical like objectives that you're trying to achieve, and what are the information systems that actually help to facilitate that, and can we represent what that pathway looks like, and then can we protect it so that you don't have any issues with executing whatever it is that your mission is.
Super cool. If somebody wants to get in touch with you, what's the best way to do that?
So LinkedIn, Jared Atkinson, or Twitter, Jared C. Atkinson, or as I didn't realize I was doing this, but Jared Katkinson. So
nice.
I get trolled about that a little bit, but I'll type it into the chat for anybody. And yeah, I'm happy to talk about this. Happy to kind of point people in the direction for the open source tool. Happy to work with anybody if they're interested in pursuing an open graph extension. We're really excited about the opportunities there. And the reason why we made it open source is we want people to contribute back so that everybody can benefit from it. So
that's awesome. Thanks a lot for coming in. And yeah, we'll see everybody next week for the next Defender Fridays.
Awesome.
Have a good weekend.
Thank you, everybody. Cheers.
See ya.